Milkshake Avenue.
Let's look at an example circuit. Later on, you're going to do what's called some series parallel combinations. And on this circuit, we have just two light bulbs that are in series with each other in parallel with a third light bulb to two batteries. It's pretty simple, but there's actually around 9 to 11 connections. And then if you measure voltage or current or resistance at any point, as many as like 13 connections. And every wire has to go in the right place exactly the first time. That's the goal there. So it gets a little bit complicated. Now, in real life, we don't just like light up cheesy little light bulbs. We might build something very complex. So for example, one year, my microwave at home broke down. It was really annoying. And I'm like, well, how hard can it be to change out a microwave? It's one of those built-in ones, and it turned out it was like $600. I'm like, that's totally annoying, because, you know, I thought I'd just get a new one for $100. So I actually took it out of the wall there, and I took it apart. I opened it, and you have to be careful because there are capacitors in there, like the Leyden jar, that can actually shock you to death if you're not careful. And since this thing is so old, it actually had a wiring diagram. And I found out that all it was missing was a little fuse. And all the fuse is it's a glass tube with a little wire inside. And that wire is designed to burn out if too much current flows. So I pulled it out. I went to Home Depot. It was like 83 cents. I shoved it in. I put my microwave back into the wall there. And bam! It worked. Life was good. So yay, understanding physics can make your life better. And that's the one time my wife was probably like, yeah, maybe it's not that annoying being married to a physics teacher. So anyhow, let's look at some circuit symbols here. So in order to communicate how circuits are built, we have some standard symbols. So for a battery, the symbol is just a short line and a long line. What that represents is the two different metals that go inside a battery. A battery simply has two different metals. One's called an anode, one's called a cathode. And usually one likes to grab electrons, one likes to let go of electrons. And then one weak acid is put in there. It's called an electrolyte, like a paste there. So for extra credit, you can look up some plans online. You can actually make your own homemade battery out of like lemon juice, pennies, zinc washers. That's called a cell. If you stack the cells together, you usually get a higher voltage then. And the rule of thumb is, this is really important, the long line, see how this side's longer, is the positive side of the battery. The short line is the negative side. Why? That's just the international standard. So that way, if you're an engineer in Germany, you can still work with an engineer in Japan. When you go shopping for a laptop, when you take off for college, the number of cells determines how long the battery usually lasts. So I think most laptops have a 4-cell battery. You want to get like a 6-cell or 8-cell one, because then your battery will last like the whole day. So that's something to look for. Next, a resistor. What's a resistor? Very simple. The goal of a resistor is to block the flow of current. There are two ways to draw a resistor. One is to draw like a squiggly pipe that's all zigzaggy, or another way is to draw it all curlicue. Either way, what that represents is something designed to block the flow of current. If you hired a plumber and they put this kind of pipe in your home, you probably want to fire the guy, right, or lady, right, and get somebody else, because that would mess up the flow of current in your home. These are what resistors look like in real life, where they have a certain carbon ceramic formulation to block the flow of current a precise amount. By the way, doesn't it seem weird like you would want to block the flow of current? Why would you ever want to do that? Doesn't it seem annoying? Why would you want to do that? Well, how about your car? Your car is a great example. In real life, your car really only has one electrical circuit powered by your battery, and then your alternator charges it up. So if you think about it, what should get more current? The headlights of your car or that little flicky light when you open and close the door? Obviously, right? Your headlights, right? Because wouldn't that be annoying? You open the door and then you're like blinded by the flicky light there. So all you do is you just shove in a bunch of resistors so you only get the right amount of current to each part. Next, lamp or bulb. A lamp or bulb has two ways. You can either draw a resistor that's squiggly or curlicue, and you just put a little circle around it. All that represents is the idea that a resistor inside of an evacuated chamber can be optimized to give off light. So usually it's a tungsten filament that's designed to block the flow of current. It gets hot. Next, the switch. A switch is just simply a wire that you break at 2 points, and then you can close the switch with like the knife switch there. Kind of like on our Red Devil circuit there, where you literally close the contact there, and it turns on. An AC power source. Let me zoom in so it's a little bit easier to see here. A squiggly line, like a wave almost, and then you just put a circle around it to represent this idea that current is shaking back and forth. The voltage goes from positive to negative 60 times a second in America to shake those electrons back and forth.